Good afternoon, YouTube, and welcome to the weekend. Needlebender 785 here in Florida, with a promised update, like I said, on what we're doing here as far as research and development. There's not going to be any high power antenna exploding million-watt transmissions on this video, but we're going to talk about some software and the things that we're kind of working on here and what we got going on. So let's just kind of start from kind of continuation of video I made yesterday. So the new game in town is this Raspberry Pi here. We got that's going to be the brains of this, all the new amplifiers, at least stuff that we're working on. It has 40 GPIOs, or general purpose input output pins. It has a lot of other stuff that we're not going to even get into right now, but things that we can look at is current meters, voltage meters, which we don't have right now, but we have a current meter. Here we go. We have a very, very high precision rotary encoder. It's actually designed for like high RPM and knows exactly where it's at all times. And we're going to look at a few things and see what kind of stuff we can get into here. I don't really expect. Let's see what we got going on here. All right, so the first thing we're going to talk about is the current meter. So as you can see, this meter is not very accurate, but we got about 99 milliamps, and we got anyway, we got amperage here, and we can turn it down and look at the responsiveness of that. And I have this meter set to 200 as the max. Obviously you can change that, you can make it in amps or whatever you need, but you know, this screen current has to be only 200. And look how responsive that meter is. And obviously this is research and development. We're displaying live value of what we're measuring. And like I said, I'm turning that knob right now to display this current. And look at this movement there. So that's one thing that that piece of equipment is right there. We're not going to take it out. Obviously it's going to stop working if we do that, but this is what this is. It's takes 3.3 volts. You can change the resistance there, and you can have as many of these as you want for as many things that you want to measure current for. And as you can see, very nice, precise, and my favorite, very responsive on-screen meter. And obviously this this does not require any kind of internet connection. This is run as a web socket locally. Obviously, if you have a local network like in another room, you'll be able to see this run an iPad. Anyway, so that's the current side of things. Voltage is very simple. Obviously it's the same thing, except the math is current, voltage, wattage, all that stuff is just a you know, it's your power equation stuff. So it's a voltage measured over loss over a resistor. It's either divided or multiplied, but anyway, the process is the same. You have an analog to digital converter that spits out data on a data bus, picks up by this Raspberry Pi. So let's take a look at something different now. We're going to stop this program, and then we're going to go close that out. And then we're going to look at this rotary encoder program that I kind of put together. And obviously I used some source code from the internet, and I wrote my own program here. And I wrote all this myself, and I also wrote this now the styling pages I copied off the internet. Just and again, there's no limit to what you can find over there on as far as the styling goes. Now here, again, this is for demonstration purposes only. It doesn't have any of the functionality it will later, but let's take a look at what we got. So we got this rotary encoder. It uses something called Flask. Flask is it's a web server in Python, and all of my stuff is written in Python and HTML, because pretty much the only Python is the main language that I know really well, I would say. I know HTML because it's just easy, and JavaScript I can get by pretty good, a little bit I guess, but that's all the languages that that we got going on here. So let's start this little web server, and let's get out of there, and then we're going to hit this start encoder, and then we're going to have this meter right here. And check this out. As we're turning the knob, we're simulating going across, turning the capacitor. In the middle, we have a turn counter. I apologize, I got a bit of a throat tickle. Obviously, this will have, you program this for however large your capacitor is. Right now I have it stop at 1,000 clicks, but also counts the number of turns. In the middle there tells you what turn you're in, and obviously the bar on the top kind of gives you the whole capacitor as it was laid out in the linear mode, and on the bottom kind of gives you positions of where it's at. So as you can see, I'm going to show you what I'm doing here. Now the sensitivity is something that needs to be adjusted, because I want this to be 1-to-1, which it is not at the moment, but that's a simple division variable that you change in there, and that lets you set. Now you just figure that it will be controlling a stepper motor that's going to position these capacitors exactly where it's at. But the whole idea of this demonstration, I just want to show you how sensitive and how precise it is with the rotary encoder, and allows you to do pretty much anything you want remotely with one knob, and you can just select capacitors with a click button and have all your meters displayed right here. And like I said, when I made the video yesterday, I wanted to kind of follow up that we are actually developing this stuff. And like I said, this is a little demonstration software I wrote here in a couple hours, but actually started working with another needle bender 44 out of Florida. He's on the other side of the state. He's been developing like a whole like a full functioning software that's going to integrate just kind of what we showed you here, but in a more way more advanced kind of a way. It's actually going to integrate with your radio, so it can swap bands and stuff like that automatically without you having to do it. Integrates controlling the relays inside the box, all kinds of fun stuff. So like I said, I did this demonstration just to show you that we have capability now to control the rotary encoder, and kind of get back to where we were. Now there's obviously going to be buttons. Instead of the stop button, there's going to be 3 memory buttons, and you can push memory and it will remember exactly where you left your capacitor. So whenever you go to your next band, all these values are stored, and then you can precisely go back to that. And I just want to demonstrate how responsive this is. And I mean, we're talking about live on the screen. This is not refreshing the page or anything like that. This is a this is an internet program. This is local net program that's displaying current position of the rotary encoder. These rotary encoders are really nice. This is $17 on Amazon, and this is If anybody's interested, that's what that is right there. It's 1,000 clicks per rotation, and very, very nice. Anyway, I just wanted to give you an update that we are actually working here and in development stages of this this particular amplifier. That's a 4CX3000. It's going to have no switches and no meters on the front. So it's going to be a first of a kind. As you can see, this is a swamping resistor, 450 ohms. It's very similar to the 4CX5000. Just the minor differences. It's a very, very similar tube actually. A little bit cleaner. But this is going to be a multi-band box. So it's going to do it all. But it's going to have no switches, and it's going to have one tuning knob connected to something like this. And it's going to have two variable capacitors and a variable inductor, all controlled by stepper motors using some variation of the software. But like I said, the whole point of this video was to demonstrate that the capability is already there, and we just have to develop it to the point where it is functional and user friendly. But it's going to happen, and it is definitely the future as far as high-end amplifiers. The days of knobs and big heavy knobs and tons of switches, and even these digital meters, they're great. But you know what? This meter does exactly the same thing. It reads an analog signal, converts it to digital. Well, why do we need all those meters? Because we still have to have all those sensors picking that up. If we take all those sensors and have one computer taking all that data and displaying it on a 10.1-inch TFT touchscreen display, where you will be able to control all your stuff, and you're going to have one knob for your rotary. And that's it. So literally the box will have one knob down the middle and 0 switches. And it's, again, always pushing the envelope with developments and stuff. And again, this is just phase 1. We're kind of looking to get, my whole goal of this thing is to make the fully automatic, where you throw a carrier and it tunes the band. Now that's going to require a lot more software. We're not quite there yet. Right now we're just doing basically your drive-by-wire kind of controls and memory functions. Electronic display, electronic meters, so that's the start. But anyway, I appreciate you watching, and thanks for following the channel. There'll be a lot more videos coming along here in the next few weeks. Needle Bender 785, here in the sand pile, we're back quiet.